to run through the next section with you, which is our part on composite functions. So we've used composite, or the term composite, before. It's just how things are made up. So when we're talking about composite function, it's talking about two functions coming together essentially. Okay, as I've said here, it's a two-step function. So it has two parts. We use a value, an input value, we input it into one function, it gives us its output. Then we use that output as the input for the second step. Okay, so you can imagine if we put one number in, we put in the number 4, it becomes the number 8, and then we use number 8 as the input for the next part of the function, and that's all there is to it. Okay, so as I said, we use one function to find a value, and then we use that value, that output, as the input for the second step. All right, so our notation is the important part here. It can get a little messy most of the time. It gives you this little bit here, which is like a little circle. Okay, not to be mistaken with the letter O, but tiny little ring or circle like that. And that's most often they come up like that. Sometimes they come up like this, but as I said, the vast majority of the time you'll see them that way. Now, the way what this means, or how we talk about, or how we discuss it, it's the composition of H and G. Okay, and as we said here, it's read, we read it as H after G. Okay, so H after G of X, if you want to read it like that. So the H after G of X. So as I said, in the cases above, we find Gx first and then use that value to apply it to H. So I find out this section first, I get that, I put in an X value into the function, it gives me a number or an output, and then I apply it to as the input for the H part of the function, because it's H after G. So I do this part first, and then I apply that value to H. And that's generally it. So I've got a couple of examples now on the next slide to show you. And these are from your textbook, page 157, question 1. So I've given you 3 examples, okay? So in this question, we're given the two functions. We're given the H of X is 2x and the G of X is x squared. And we're looking for H after G of a certain value. H after G of a certain value. H after G of a certain value. Nice and straightforward. So I find G, first of all. I find the G of whatever value I'm looking for. So I substitute in whatever number I'm looking for, and in this case it's 0. I substitute that in to the G function first and foremost. Then I get a number for that. It is the output, but it becomes the input for the H part of the function. And then I substitute that number in to the H function. So in this case it's 0. So I'll substitute in 0. So G0, I substitute in with 0, that becomes 0 squared because it's x squared, which is 0. And now that's my output. As you can see, I've popped in the arrow there. It becomes the input for the second section. It becomes the input. 0 is now the input on the H part of the function. So I substitute substitute 0 into my H function, and it becomes the H of 0. So that's 2 times 0, which is 0. So you can see I've finished that off then by writing this part here. H after G of 0 is 0. Because that's what I'd asked for at the start. So I'll just rewrite that again at the end. And that's all there is to it. Now it might be a little bit confusing because the number doesn't change in this one. So that's why I've given you more examples. I might make it a bit clearer in the next ones. Part 2. I'm looking for the H after G of 3. So I use 3. I substitute that into my Gx function. So you can see that the G of 3 becomes 3 squared, which is 9. And then I'm using 9 as the input for the H function. The H of 9 becomes 2 times 9, which is 18. Because my H function is 2x. So I can say h after 3 in this case is equal to 18. And then finally, I've got to do a negative value in this case. I've got the h after g of minus 6. So I substitute minus 6 into my g function first and foremost. Minus 6 squared becomes 36. And then I've got the h of 36. So I substitute 36 in as the x value in the h function. So that becomes 2 times 36, which is 72. So my h after g of minus 6 is equal to 72. Now the process is no different for any one of these. You're going to be given two functions like we have been done in this question. You're going to have to use one and then get the output and pop it back in to the second one to get your final answer. The notation might be different. I'm going to slide back to the first slide here. The notation might look like one of these four, as I've mentioned, but the process is no different. The function is going to change. So up here, if you look at this thing is going to change and this thing is going to change, but the process won't. So everything that you've seen here, it will follow suit, bar having to do specific things with these functions. It might be 3x plus 4, or it might be x cubed minus 2, or whatever it might be. But that's all there is to it. So take your time, give it a go. Thank you very much.